It's very, very much a pleasure to be here, and thank you so much for the invitation to come to the Faculty of Engineering here at Strathclyde and to talk to you about engineering issues. It's always nice as chairman of the Health and Safety Executive to talk to engineers, because I don't have to preface any talk I give to an audience like this with making it clear that I'm not here to talk about banning conkers and all of the other nonsense that a lot of people associate with health and safety. I take it as read that many of you, like me, know what real health and safety is about, and I hope that by the end of this talk this evening you will have given even more thought to how integral it is to the role of every engineer. Because I've spent most of my career, as you heard, in the major hazard industries, and that was when I really, really got to understand what health and safety was about. I was actually at university when Flixborough happened, for those of you in the room who can remember, when Flixborough happened in 1974. So I went into industry with my eyes wide open about just how big an issue safety was going to be in my career. And since I've been chair of the Health and Safety Executive, I now get to see those issues around process safety, asset integrity, engineering management, whatever you want to call it, and we'll use all of those terms in the next half hour or so. But I now see it from the perspective of the regulator. And I tell you at the outset that some of what I see since I've moved into the role of the regulator, I'm not terribly happy about. So much of what I want to talk about and what I'm going to cover in this lecture will be based upon the work of the Health and Safety Executive's Chemicals, Explosives and Major Hazards Division, and also our Energy Division. And I'll explain a little bit more about the difference between those two and where they work together. What I'm going to do is provide a brief description of some of the work programs which are underway in these divisions, and an insight into some of the things that we're seeing and some of our observations on what this means in terms of challenges for industry and the people who work in it. I'm also going to say a little bit about the roles that engineers actually play working in HSE, how they're central to that work of what we do and how we interact with people in industry. And it's also worth saying that the work within HSE that I'm highlighting is an important facet of what is in itself a well-engineered organisation. HSE has recently celebrated 40 years of operation. We were formed 40 years ago in January. And when I say celebrate, I do mean celebrate, because we have here in Great Britain one of the best health and safety records in the world, and a health and safety system here in Great Britain that others in other parts of the world want to learn from and want to emulate. We don't often recognise that. So why would that be? What is it about the way we do health and safety in this country, in Great Britain, that makes it so strong? What we have is a far-sighted architecture of the Health and Safety at Work Act. What is key to the Health and Safety at Work Act is the principle that those who create the risk must also manage the risk. There is a regulatory framework formed by the Act and the regulator, of course. HSE and its various experts and specialists, combined with its agency, the Health and Safety Laboratory, which I'll talk again about more later in my talk, give us a unique capability. But at the heart of our system is that principle that we don't tell the duty holders what to do, we tell them what the outcomes are we want them to achieve, and that risk management rests with the people who own the facilities. But our knowledge also enables us as a whole organisation to learn and to feed into the development of new policies and revised regulations So we keep the regulations up to date, we keep them appropriate, we keep them proportionate, and we have specialists in many disciplines within HSE. And whilst the focus this evening is on engineers, both those required by HSE and by industry, it's also important that we recognise that we, like you, will be working in a multidisciplinary environment. So let's move on to some of the areas that I'm going to talk about. I don't think it will surprise you when I say that both on and offshore, we are seeing a general shortage of good integrity management engineers in the industries that we regulate. For this part of my presentation, which will be much less about technical issues and much more about how we inspire and encourage new and recent graduates to come into industry and work with us on these challenges, I'm going to draw not just on my role as chair of HSE, but also on some work that I've been involved in for the Royal Academy of Engineering, and also some of the knowledge that I gathered whilst I've been involved with the Institution of Chemical Engineers as well. One of the greatest challenges that I think we as engineers face is in finding much better ways to tell our story to other people. We need to make what we do come alive, and we need to inspire others to follow. When John Perkins and others tell us that there's a shortage of engineers here in the UK and more broadly, that isn't just a problem for the future. It's not about a supply chain that will be a problem in the future. It's a problem in the here and now. So whilst the main focus of what I'm going to talk about later tonight is about leakage from physical pipelines, I also want you to remember that we have a serious issue to address in terms of leakage from the talent pipeline in getting people who start off studying engineering to stay with the discipline. But let's start with some of this technical stuff that we have observed. And I apologise, I'm not going to talk about new and high-tech facilities tonight. I'm going to talk about some more mundane things because that's where some of the biggest challenges lie for engineers. And I'm going to start with plant ageing and looking at how all of this fits in with the work that we're doing in our onshore area first, and then I'll come on to offshore later. We carried out some research in HSE during the period from 2008 to 2010, where we looked at the overall age of the facilities that are still being used. And as a result of those findings, this whole subject of ageing has become quite a strategic priority for us. It goes without saying, I hope, that asset integrity management was already part of our intervention strategy at major sites, but in doing the work that we did after that research, we recognised that we needed to ensure that it was much more integrated into the day-to-day work of all engineers, but in particular the mechanical engineering team. And our revised approach, which we started some 5 years ago, had three clear aims. We needed to measure the performance of ageing management at individual sites. We needed to drive improvement in performance. Having measured it, we need to improve it. But we also need to get people talking to one another, to identify common cross-sectoral issues which can be shared and elevated and tackled at professional and trade association level. There's too much isolated thinking going on. One example for me is that when I talk to audiences of mechanical engineers, they talk about asset integrity. When I talk to chemical engineers, they talk about process safety. Is there a difference? Because I can't see it. But we've all developed different languages and we're erecting barriers that really don't need to exist. So over the 4 years of this strategic programme that we've been running, we've found some key issues, but we've also started to make some progress. But before we get to the progress, let me give you, I said at the start that some of what I've seen bothers me. Here's one of the findings that bothered me. The key finding that stuck out for me from that research was that 70% of all of the sites that we looked at needed to improve in at least one area of their asset management, ageing asset management. Now, this isn't just about engineering. We know that we need to see senior managers as well as engineers playing a vital role in focusing this effort and the resources into integrity management and ageing plant. Because it's those senior managers who need to take positive action to assure themselves that arrangements to address plant ageing are in place. It's those senior managers who will allocate sufficient resources with the right level of competence. It is they who have the means to measure and assess the effectiveness of the ageing plant regime through using and having reported those indicators of performance. And even more importantly, it is those senior managers who need to respond positively when the engineers present the data and indicate that resources are required, plant downtime or capital is needed because plant integrity and the long-term integrity of the facilities is being threatened. And it is those senior managers who need to ensure that everyone, up to and including the board, has a realistic and accurate picture of the condition of the plant, and it is part of their risk register, because all too often we see risk registers that are all about financial risks, but which do not fully reflect the mechanical integrity of the assets which lie at the heart of the business and which can wipe out the rest of the risks that people are looking at literally overnight. So, to be clear, what I'm telling you is that from our current sample, which was about 400 sites, which we visited, we found 70% of them failing to match up on at least one, or in some cases more than one, of those principles that I've just said about the management commitment to this process. So how big a problem is that? I've said we looked at 400. In Great Britain as a whole, we have close to 1,000 major hazard sites. So that means that some 650 to 700 major hazard sites onshore here in Great Britain are failing to match up to the standards that we would expect of them. It's my job to make you feel uneasy. One particular issue we've identified, and let's put some facts around this. I'm not going to go into all of the things that are wrong, but let me just give you one simple example of how people get this wrong. Onshore sites very commonly use third parties to provide ageing plant management services, particularly to do inspections. And what we found is that when they outsource that, what we see is significantly poorer performance when it comes to that management process. Now, third-party services are used a lot by a lot of industries, frequently contracted through the site's insurance company or the broker. And that's long been the practice for statutory inspection of air and steam generating pressure vessels, as some of you will know only too well. But what's happened is that if people have recognised the need to do more on asset integrity, they've simply extended the contract and asked people to do a bit more, without stopping and looking in some detail at the differences. When you move into asset integrity, people need to understand far more about the process. They need to delve into the way things are managed. It becomes much more of an in-depth exercise than some of the more straightforward generic equipment inspections that will be required for air and steam pressure vessels. So we're moving into a place where people are being asked to do things which are, strictly speaking, outside of their competence. And that failure to recognise the different competencies required to do integrity management have proven to be a frequent cause of inadequate arrangements being in place. So, relatively simple to fix. Integrity management inspectors have to have access to and be able to interpret details of specific process conditions. So you've got to find people with the right skills to do that. Almost inevitably, it means that that service is going to cost more. It might require a different contractor even. But that means that the client themselves has to become more intelligent. They have to think about what they need rather than simply doing something because they want to tick the box to say that inspection has been done. You don't have to do all of the work yourself. There is plenty of good guidance out there. We've already worked with a lot of organisations that help industry, like the Engineering Equipment Material Users Association and the Safety Assessment Federation. There's lots of good guidance there on how to do this. So there really is no reason why this cannot be done, because the advice on how to do it is there. I don't want this lecture to be all about me standing here and telling you that nasty things can happen if people don't get ageing plant and asset integrity right. So what I've included in my presentation, and to give me a rest from talking as I recover from this cold, is an actual example of when people don't take care of asset integrity, just how badly wrong it can go.
The Chevron Richmond refinery lies approximately 10 miles northeast of San Francisco in California's Contra Costa County. The 2,900-acre facility was initially established in 1902 and primarily makes transportation fuels, such as gasoline and diesel, as well as lube oils. The refinery can process up to 250,000 barrels of crude oil per day. The first step of the refining process takes place in the crude unit, where crude oil is cleaned and heated before entering the distillation tower. Inside the tower, the crude oil is boiled. The vapor then condenses into various liquid hydrocarbon fractions, or streams, including jet fuel, diesel, and gas oil. The different streams exit the distillation tower through separate pipes or side cuts that lead to other sections of the refinery. On August 6, 2012, the crude unit was operating normally. Around 3:50 that afternoon, an operator was performing a routine check when he noticed a small puddle on the ground near the distillation tower. The liquid appeared to be dripping from an 8-inch insulated pipe 14 feet overhead. The leaking pipe was a section of the tower's number 4 side cut line, which operated at a temperature of 640 degrees Fahrenheit and contained light gas oil, a combustible liquid similar to diesel fuel. Chevron inspectors knew that over the years, the walls of the number 4 side cut had thinned due to corrosion, but they did not realize how close this particular segment was to failure. There was no shutoff valve between the pipe and the distillation tower, and no way to isolate the leak. The head operator was called to the scene. Although he believed the situation was serious, he did not believe the small leak warranted immediately shutting down the unit and stopping production. Following Chevron's standard practice for responding to hazardous leaks, refinery firefighters were sent to the scene. A number of managers, engineers, and technicians gathered there informally to assess the problem. The group discussed a recommendation from an operator to shut down the unit, but they decided to first try to pinpoint the leak by removing insulation from the pipe while the crude unit was still running. They hoped they could stop the leak with a temporary metal fitting known as a clamp. A Chevron firefighter tried using a pike pole to hook and pull away the insulation, but this poking action was deemed too dangerous because it was moving the pipe. The CSB later found that the tip of the pike likely caused a small puncture in the already thinned pipe. As the unit continued to operate, workers assembled scaffolding directly beneath the leaking pipe. 2 firefighters then used a hook to remove the insulation from the pipe. As they were working, hydrocarbon vapor began to flow out from underneath the insulation. The 2 firefighters backed away from the growing vapor cloud. As the hot vapor mixed with air, it ignited. That fire was quickly put out, and the 2 firefighters immediately climbed down off the scaffolding. But the exact location of the leak was still obscured by the remaining insulation and firefighting water. So the Chevron firefighters attempted to strip the insulation off the pipe with high-pressure water. But the leak suddenly worsened, and hot hydrocarbon liquid started to spray out of the pipe. A decision was finally made to begin an emergency shutdown of the crude unit. But it was too late. Suddenly, the pipe ripped open. A vapor cloud formed and rapidly expanded as the large inventory of hydrocarbons in the distillation tower started to vent through the ruptured pipe. The vapor cloud immediately spread over hundreds of feet, engulfing all 19 people who had gathered nearby. The firefighters and operators struggled to escape through the dense hydrocarbon cloud, unable to see. They had to feel their way out, some on their hands and knees. At approximately 6:30 p.m., 2 minutes after the huge vapor cloud formed, the hydrocarbons ignited. One firefighter was trapped inside a fire engine when it was suddenly engulfed in flames. He radioed for help.
Mayday, mayday, mayday! This is phone 60!
But when he received no response, he assumed everyone else was dead. To escape the inferno, he fled through what witnesses described as a wall of fire. Fortunately, all the workers would eventually flee to safety, and there were no fatalities. The towering white vapor cloud could be seen as far away as San Francisco on the unusually clear August day. After the ignition, a dense plume of black smoke formed and drifted away from the refinery. The fire continued burning for hours. Over the succeeding days, more than 15,000 people sought medical treatment at nearby hospitals for breathing problems and other symptoms. During its investigation, the CSB determined that the carbon steel pipe, installed in 1976, had thinned to the point of failure from an effect known as sulfidation corrosion. Carbon steel piping is particularly susceptible to this type of corrosion, which occurs over time when the steel is exposed to sulfur-containing hydrocarbons at high temperatures. Steel piping that happens to be low in the element silicon corrodes especially quickly. The CSB learned that sulfidation corrosion had caused a major failure at Chevron's refinery in Salt Lake City, Utah, in 2002. Chevron then performed an enhanced inspection of the No. 4 side-cut pipe at the Richmond refinery. It revealed accelerated thinning in the piping section that would ultimately fail in 2012. Replacement was recommended, but this did not occur, and the section of piping was never inspected again. In 2009, Chevron experts recommended that every segment of high-risk carbon steel piping be inspected for corrosion. However, this was not done. During a maintenance turnaround of the crude unit in 2011, Chevron inspectors examined some, but not all, locations along the No. 4 side cut and found significant thinning. Some sections were replaced, but managers decided that the line was thick enough to stay in service and that an overall replacement could wait up to 5 more years. According to CSB investigators, a key lesson is that each and every segment of the piping should have been inspected. Most importantly, the pipe should have been replaced much earlier with an inherently safer corrosion-resistant alloy. The CSB also concluded that had the crude unit been shut down when the leak was first noticed, the massive fire likely would not have occurred. The 19 workers would never have been endangered, and the community would have been protected. For more information on the CSB Chevron investigation, please visit csb.gov.
Okay, so I hope that illustrates a number of the points I've already made to you. Was that a process safety incident, or was it an asset integrity incident? I don't think it matters, does it? The consequences are clear. When we talk about managers making decisions they're not competent to make and judgment calls they're not competent to make, 10 years of this can wait. How did they make those decisions? So we can see from this example, I think, that when you have poor long-term leadership of health and safety, it causes a problem, clearly. It allows a problem to run undetected for a very long time. And to me, if the health and safety culture from the leaders at the top is as poor as it clearly was there, I don't think we should be too surprised by some of the extraordinary behaviour you saw among the firefighters and the operators. Because quite clearly the whole culture of the organisation was not right around this whole issue of dealing with hazards. So that was an accident waiting to happen, and I think it's just worth thinking it through. It's not just a piece of pipe that's thinning. That's where you start, but that's where it ends. So let me now move on to talk about offshore here in the UK. And again, it's a story of managing old facilities, ageing plant in our offshore oil and gas facilities. We have been very fortunate to have had 40 plus years of oil and gas production. And with over 50% of the fixed platforms now having exceeded their original design life, asset integrity is clearly a major priority and will continue to be so. With an enhanced oil recovery, the potential for platforms to be pressed into different services because they've been designed to be flexible, and because we continue in Great Britain to rely on oil and gas as a major source of energy alongside other increasing renewable sources, the fact is that those facilities, although beyond their design life already, are planned to remain in production for the foreseeable future, notwithstanding where we are today with oil and gas prices. This isn't a new problem. The offshore industry should have learned from experience the dangers of making assumptions about the likely lifespan of facilities. We've had low oil prices before. Before the turn of the millennium, when oil prices were low previously, assumptions were made then that facilities would be quickly decommissioned. Some 15 to 20 years later, those facilities are still operating. I hope that the mechanical engineers in the audience, and many others of you as well, purely from common sense and from running your own cars or whatever you base your knowledge on, will know that it makes absolute sense that maintaining the integrity of any asset is a very different task from rebuilding integrity after it's been allowed to decline. We're in another period now of low oil prices, and it's essential that we see industry respond appropriately to this current economic situation. They must not make the same mistakes they made in the 90s. They must not undo all of the good work that they've done in catching up since then. But this does raise an interesting aside about when do you start worrying about this whole subject of plant ageing. It's not something that you wait until you've had the facility for 30 years before you start to worry about. From the day the plant is commissioned, it will be subject to change and to challenge. Plants start to age from day one. The process itself immediately turns a clean, pristine plant into a live process-contaminated plant. Corrosion and mechanical degradation of the plant, the instrumentation, and the overall structural integrity, especially in harsh environments like the North Sea, begin from the moment the plant is commissioned. Even more so than with us as human beings, premature aging of facilities needs to be avoided by taking care of the assets from day one. But let's go back to offshore and continue this story. Because as I said, following neglect, and it really was neglect during the 90s, in the new millennium, our offshore division, as it was known then, found those substantial shortcomings in integrity management as a result of cost-cutting and maintenance backlogs. A situation that was very, very concerning. And it was already resulting in an associated increase in the number of significant hydrocarbon releases. So our response at that time as a regulator was to undertake a programme of work. We called it KP3 on asset integrity between 2004 and 2007. And we were looking in particular at the risk of failure of safety critical elements. That report, when we published it in 2007, revealed significant issues on maintenance of safety critical systems on all offshore installations. The report was made public, and the findings were very quickly, I have to say, acknowledged by industry. It raised serious issues, and the Secretary of State commissioned further review. I'm also glad to say that that review, when it was commissioned, found that industry had woken up. They had allocated considerable resource and effort to improving the assets and did make a very good start on catching up. But as I said, this is not something you can turn on and off. It was never, ever going to be a short-term fix. The considerable effort which had gone into catching up has to be maintained and sustained. And with this in mind, we've since had KP4, an ageing and life extension programme. We've been looking at how duty holders are planning to deal with asset integrity management for the long haul, and it's comprised targeted inspections of plants to assess the conditions through sampling. Last autumn, we completed KP4 and we've made a number of important recommendations to industry about the need to continue promoting ageing and life extension. We must never allow this. We've done it, we've fixed it. We no longer have to put money into this. The need to develop and get the right corporate culture in place is also a constant challenge because people are constantly changing. You educate one set of managers, they move on, you have new people coming through the system, you have to bring them up to speed. You also have to deal with the fact that as plant ages, some of the pieces of kit become obsolescent. So having available spare parts, being able to keep those pieces of equipment together becomes more of a challenge. You have to remember what assumptions you've made about life extension and what levels of assurance you need to build in as things get older. You need to think about how you are going to decommission equipment when you decommission it. And you also need to ensure that you keep good records, that you involve the workforce so you know what their concerns are, and that you have people with the right skills who can manage this whole programme. So now let's look at the broader landscape. As with the onshore industry, with trade bodies, in this case Oil and Gas UK, we're working on keeping the offshore industry on this subject of ageing and life extension. We're participating in the steering group. And if there's anything that's surprising for me in all this, and I hope you are already starting to wonder about this, is why is it that the regulator keeps having to remind people that this is important? Why is it that the regulator is telling industry that it has to look after its assets? Good long-term safety management, dealing with the potential for failure before the failure occurs, is not about doing what the regulator wants. It's about improving business reliability, improving profitability, avoiding getting your company into the position where your whole livelihood is threatened because you've had a major incident like the one we saw there. There is no doubt that the role of engineers in delivering all of this is hugely important. But that role is not just keeping the health and safety inspector off the back of the company. The role of the engineer is fundamental to business success. This is the heart of the issue which we have got to get across to business and make asset integrity and reliability a much more important business issue, not something that is delegated to the engineering community or being done because the regulator's forcing the pace. The fact of the matter is that all industrial infrastructure is continually ageing, and it's simply not possible for all engineers to go and work with brand new kit. All of you who work in industry will at some stage in your lives work with aging assets. You heard that I worked in industry for more than 30 years. I never once ran a brand new plant. I commissioned changes and improvements, yes, but I always worked on plants that were at least 20 years old, some much older than that. And I don't think things have changed. Certainly in parts of the process industry that I am still associated with, some of the kit is very old indeed. There continues to be pressure on everywhere to keep plant running for as long as possible. And I don't think that's a bad thing, because in actual fact, it is a tribute to the quality of our predecessor engineers, and indeed some of us here in this room who designed and built those plants and those facilities that have that capability to run way beyond their design life. That is a tribute to good engineering, but only if we preserve those assets. It is rarely the design capabilities of the plant which are found to be wanting. What is found to be wanting is the care and attention that's been given to the facilities during its operating life. So we start with good kit, we then don't look after it. Managers and finance directors use very simple measures of performance to drive down operating costs. They compare costs across plants regardless of age, not recognising that old plants need more time and attention than new plants, that there's a need to tackle unattractive and mundane issues like corrosion under insulation. And it's that short-sighted approach which leads to much higher costs in the long term, and the problem being more costly to fix also in the long term because it's been left, in some cases, literally under wraps. So why does this happen? Well, there's a number of reasons. One I've already mentioned is skills shortages. The problem's been exacerbated by a shortage of in-house skills, no doubt, to carry out the work. Some of those risks, as I said, handed over to outsourced third parties who give assurance when they shouldn't. And one can add to that list changes in asset ownership, which further challenge an organisation's ability to maintain good records of inspections, of what's been done, what things are being used for. Are the original design calculations even there to go back to? Are the drawings available? All of these are real challenges. But as I said, I still believe that leadership is key. Leadership in health and safety is absolutely vitally important. It's the job of those at the top of every organisation to lead the way and to make it part of their business, especially during times of turbulence like the current turbulence from the oil price changes. This is when leadership is really tested in terms of staying true to those long-term commitments in the face of short-term pressures. I mentioned earlier that engineers cannot reasonably be expected to work with shiny new kit. But that's different also, I think, from acknowledging that a lot will be attracted to do so. A lot of people will want to work with new technologies, in new parts of the industry and in other parts of the world, where investment levels are several orders of magnitude higher than here in the UK, and salary packages very tempting. And even here in the UK, we can see salary gaps emerging between different sectors. So this brings me on to the second part of my talk, which is about the importance of engineering and what we need amongst our engineering community. I've highlighted, I hope, in what I've said so far, why engineers in industry must be recognised as being important, why they must be confident, and why they must be able to communicate their needs within the organisation, because they have to get attention on these things that matter. Even in HSE, we also need to employ competent chartered engineers who are confident and able to challenge their peers in industry to ensure that those regulatory requirements are being met. I often speak, and I've already said tonight, that I believe one of the strengths of our regulatory regime is our goal-setting principles. But we mustn't forget that when it comes to the people we employ, that makes their jobs particularly challenging. We don't employ inspectors in HSE to walk around with clipboards and to check for compliance. We employ people who are prepared to exercise professional judgment, to have that judgment challenged by duty holders and ultimately in the courts. So they need to be competent engineers who can take personal responsibility for the decisions that they make and the advice that they give. They also have to be supported by deep topic specialists in our laboratory and in our head office. We employ experts in metallurgy, in stress analysis, fracture mechanics, and stress and forensic investigation. So we have to have all of those skills. And to give you a feel for some of the things that we're currently looking at, and looking at from a health and safety perspective, but nonetheless from an engineering perspective, we're considering onshore well integrity associated with fracking, because we will be regulating that. At transport and storage of carbon dioxide associated with carbon capture and storage, an assessment of integrity and certification of petrol tankers. So all of those things are areas where you clearly need to be good at engineering. But what about in industry? The role that engineers in industry play in aging asset management is also very important. And it's far from being just about the technical bit. And this is really important. Yes, your role's about developing schemes of examination and reviewing reports. It's about liaising with other specialists and ensuring they carry out the right work, of course, of championing asset integrity in your own organisation. This is when it starts to get beyond engineering, because you will have to petition for capital expenditure. You will have to stand up and ensure that other plant pressures are not allowed to compromise those integrity programs, as well as developing those technical skills. Let's be honest, it means at times you will have to stand up and say stop when others will regard that as really unwelcome. In short, you all have to be leaders. So I hope you can see what I've spoken about so far, that as well as a multitude of interesting challenges in this health and safety space, and I've only talked about one aspect of it from an aging asset management perspective tonight, but there are huge opportunities here for engineers. For mechanical engineers that are here in this audience this evening working in industry, I think there is a real opportunity to raise your own profile in this whole area around asset integrity and aging management, among other things. Many senior boards know it's an issue, but they also know they need help. You have an opportunity to be part of the solution, not part of the problem, simply because you're always pointing out the things that go wrong. But if we're going to do that, if we're going to do any of those things, we have got to make engineering more attractive, and when we become engineers, we have to develop new skills. Despite the need for more engineers being widely publicised, you can pick up newspapers any day of the week and see about engineering shortages. We're still not seeing the sort of increase in the applications to study engineering that we need. There are some exceptions. It just so happens that chemical engineering over the last decade or so has seen the number of people applying for and being accepted onto ChemEng courses more than double. And as I speak today, every chemical engineering course in this country is full, with several other universities in the process of establishing new ChemEng courses to meet demand. And for me, it's particularly encouraging to see the increase in the proportion of women applicants. That's all good news. But the reason I mention chemical engineering and what has happened is not because I happen to be one. It's because of the different thinking that went into attracting engineers into the profession. It came about in response to a problem, to a crisis when the number of applicants dropped to an all-time low around the turn of the millennium. And the professional institution at that time recognised that part of the problem was people didn't know what chemical engineers did, didn't know what it was about, didn't know what the discipline was about. So a lot of effort has gone into doing a much better job of explaining what chemical engineers actually do and describing the wide range of career opportunities that are open to graduates. And it's that change of language and that change of approach that has worked. So for chemical engineers, the challenge now is, having got all of those people inspired to study chemical engineering, we have to move our efforts on to persuading them to stay in engineering beyond graduation. I'm back to fixing that other leak in that other pipe, which is the talent pipeline of getting those people into industry. There are skills shortages wherever we look throughout the engineering profession. We all need to talk differently about what we do and what we all get out of the rewarding profession that we have chosen. I have said many times, and I will continue to say, that we as engineers are great at talking to one another, and I am enjoying talking to you tonight, and I hope you are enjoying listening. But we talk a common language. We understand one another. We are nothing short of rubbish when it comes to talking to others and to explaining to them what we do, because we don't change our language, we don't adapt what we talk about for the audience. I'm very conscious of the fact that I'm standing here talking to engineers tonight. If I were talking to a different audience, my presentation would have been very different. How would have I explained what I was here to talk about? Well, I would probably have started by talking about the essential role of saving lives, protecting the environment, preventing catastrophic incidents. I didn't need to tell you that because you know that. But for a different audience, you must not take it for granted. I would also talk about our long-term heritage of some of the best engineering in the world. Again, we don't talk enough about how good we are, about how that engineering has contributed to the quality of life and the benefits which we all take for granted. I'd talk about the economic and the social importance of us continuing to operate the fine facilities we have in place, which provides us all with energy, fuel, clean water, healthcare and consumer products. Quite simply, I would speak with pride about being an engineer in the hope of, first of all, inspiring others to follow in my path, but also getting other people to recognise the value of what we do. We simply do not do enough of that. We complain as engineers that we're not valued. I've lost count of the number of people that tell me it's the BBC's fault because they've never done a programme about engineers. Well, I actually think it starts with us. It's our own fault. We don't do a very good job at all of explaining our role and our value to the world. Institutions like the Faculty of Engineering here at Strathclyde are important, of course, for bringing like-minded people together. But there's also a great opportunity which we all need to seize if we are to meet the challenges out there in the world of engineering. Explaining what we do, using a non-technical language to our peers, to our bosses, to stakeholders, to future engineers. We have to appeal to many different audiences. And when we do that, we will ensure that we have the resources to carry on doing what we all do, which is creating a better world. Many of those ageing plants that I've talked about tonight will be operating long after not just I have retired, but many of you in this audience. But it is not just the assets that we need to hand on. We need to hand down our knowledge as well as the assets. And we have to inspire pride in our profession. Thank you.